guys, welcome to AMK Resource World. Your success, our motto. In this video, we are going to learn about working principle of full wave center tap rectifier. Okay, let's learn the working principle of this full wave rectifier circuit. And this is a center tap full wave rectifier circuit. You can see the circuit here. It has two diodes, D1 and D2, and also it has a center tap transformer. You can see here this is a center tap transformer which has primary winding and secondary winding. So the input AC supply is given to the primary winding here, that is Vs, source voltage, supply voltage, and you can see here how this Vs appears at the secondary winding, which can be used by these diodes for rectification. So here during positive half cycle, let us say this is plus and this is minus. See how we represent our AC supply graphically. You can see here this is the input supply voltage graphically, which has been represented. It is a sinusoidally varying function. The signal changes sinusoidally because it's an alternating current or alternating voltage. So here during positive half cycle, see when this positive half cycle appears here, this will be plus, this will be minus, and the same thing carries forward in the secondary winding. You can see here this will be plus here, plus and minus here. Now this plus is connected to anode of the diode and minus connected to cathode. So we can say that diode 1 gets forward bias, that is turned on. Whereas if you observe here for diode 2, so minus is connected to anode, and if you just go like this, plus is connected to cathode. So we can say diode 2 is reverse biased, that means turned off. So during positive half cycle at the supply voltage, D1 is forward biased, D2 is reverse biased. You can see here if D1 is forward biased, it is turned on. If D2 is reverse biased, it is turned off. Now the current starts from here, from this positive terminal, and it flows through this D1, passes through the load and completes the path and reaches to the negative terminal. Finally, load current flows, gets conducted through this load resistance RL. That means at the input, if you have positive half cycle, the same positive half cycle will appear at the output. We get the load voltage VL here, the same load voltage, as well as we get the same current at the output. So this is our IL, this is our VL. These are the outputs of this rectifier circuit which we measure across RL. Okay. So what happens during negative half cycle? See, after positive half cycle, immediately we get negative half cycle. So when negative half cycle comes here, let us say here, so this will be minus and this will be plus, and this will be minus and this will be plus. So if you observe here, minus, okay, during negative half cycle, what happens? This will be minus, this will be plus, minus, plus, plus, right? So minus is connected to anode of the diode and plus connected to cathode. We can say that this diode D1 gets reverse biased. So if it is reverse biased, we call that diode as switched off. So you can see here, so D1 is switched off. Whereas if you observe this diode, plus is connected to anode, and if you go like this, minus to the cathode. So now we can say that diode D2 is forward bias. So it is turned on. So during negative half cycle of the input supply voltage, D1 is reverse biased and D2 is forward biased. This is off, this is on. So now the current starts flowing from here through D2 and it follows this path, goes through the load and finally reaches to the negative terminal. So that completing this path, and finally the load current passes through the RL load resistance. That means the negative half cycle appears at the output, but it is not in the opposite direction. It has been, the direction of negative half cycle has been changed. Why? Because you can observe during positive half cycle, the direction of the current through RL is downward. Even in negative half cycle, the circuit has been arranged in such a way that the current which flows, it flows in the same downward direction through IL, nothing but the same direction the current flows in positive half cycle as well as negative half cycle through this load resistance. That's why we get this negative half cycle get inverted to positive. That means the direction, opposite direction has been changed to the forward direction. Okay, so therefore we get the negative half cycle but in the opposite direction. We are passing that current in the opposite direction of that negative direction, which actually has to go if we don't provide such kind of any arrangements. Okay, so that's why we are calling this circuit as a rectifier. So why? Because it is converting this bidirectional to and fro bidirectional current into unidirectional. So we call this unidirectional current as DC, but still it is not pure DC because it has still some ripple content, some AC components. So those AC components can be reduced by using a kind of capacitor filter, which we will discuss in the next upcoming videos. So this is how a full wave center tap rectifier works. Guys, keep watching our videos for more such relevant topics of your interest in our channel AMK Resource World. Your success, our motto.